This is the screen that you see when you open the software with a mechanical draft cooling tower automatically loaded. The next step then for your design is to specify the atmospheric conditions. You can enter it here. There's a separate video on that. And then the next step is to input all the dimensions of the cooling tower. Here you see a block where you enter all the dimensions, and here you see the cooling tower based on those dimensions. If you make a change in this block here, it will automatically change the dimension here. The dimensions are as follows. H9 is the height of the cooling tower. H6 is the height of the fan above ground. H3, that's the height of the rain zone, and it's also the height of the cooling tower where air enters the cooling tower. LF1, that's the length of the fill. WI, that is the width of the cooling tower. BI, that's the breadth of the cooling tower. That's the dimension going into the screen. And that dimension times H3, that's the inlet air area on the one side of the cooling tower. LSP, that's the length of the spray zone. LDE, that's the length of the drift eliminator section. And HPL is the height of the plenum chamber. If you change any of the inputs, let's say you change dimension H9, which is the height of the cooling tower, it's currently 12.5. Let's make it 15. If I make that change, you can see that it automatically changes the dimensions of the cooling tower. The one dimension that is not entered on this screen is the fan diameter. Here you see the fan diameter. Here it's 8 meters. And it also gives the equivalent dimension in feet. For the fan dimension, you go to the fan tab, where you have to enter the correct fan diameter here. More info on that later. It will only be really necessary to enter all these dimensions when you run the software in verification mode. That is where you have all the existing dimensions and all the existing specifications of a cooling tower. You go, if you solve here, you can see there's verify. That's the verification mode where you want to solve for an existing tower. Then you go to dimensions and you can enter all those dimensions here. However, if you run it in design mode, it's not necessary to enter the dimensions here. Then it's only necessary to enter the drift eliminator and the spray zone dimensions, but the rest will then be calculated by the design algorithm, and these dimensional relationships are then used in that design algorithm, but more on that later. One can also specify the number of fans per cell by changing the value here. This is generally only used in verification mode for an existing cooling tower that have more than one fan per cell. In design mode, it is always assumed that the number of fans per cell is 1. The last input needed on this screen is the frontal area specification of the fill. By default, it is set as 1. That means that it will use the full available area of the fill, which is the width multiplied by the breadth. If you want to allow some safety margin in the design, you can make this less, like 95% or 0.95. If that area is known, you can also enter that area and select the actual area, and you can enter the area here. If you know it's 120 square meters that's available, or the fill that is packed into the cooling tower, you can enter that there. If you select an area that is greater than what is actually possible by multiplying the width times the breadth, it will give you a warning when you hit the solve button. As already mentioned, the dimensional relationships are mainly used in design mode, but you can also use them in the verification mode where you specify a cooling tower manually. If you click on the dimensions from the fill height, the width of the cooling tower, the height of the spray zone, and the height of the drift eliminator section, these are the 4 dimensions indicated in white in the dimensions area. All the other dimensions indicated in blue, that's the same color as this button, and by using these relationships, it will use the values in these white areas. If you click on it, it will change the rest of the dimensions based on the dimensional relationships, and you can see there they change. This feature is very useful if you entered dimensions that do not lead to practical cooling towers. For instance, let's say the H6, let's make that value less, let's make that 8, and let's wait for this to change. You can see it's a nonsensical cooling tower that you've specified. Now if you click on the dimensions button, it will correct that for you. There are 2 more tabs, the fan coverage and fan layout, that you can click on. Now these tabs are not necessary for the design of the cooling tower, but it just guides you in the design of the cooling tower. The first tab is the fan coverage tab, and this is just design guidelines that help you to make sure that the fan cover ratio and the plenum chamber height is adequate. In the fan coverage tab, you see the top view of the cooling tower. Ignore the green lines for now. The square you see over here, that is the width and the breadth dimensions that you've specified. At the bottom, that's the side view of the cooling tower, zoomed into the plenum chamber and fan only. The top view checks if the fan cover ratio is adequate. The fan cover ratio is the ratio between the area of the fan divided by the area of the cooling tower. If that area is too small, it's not recommended by the API. They recommend a fan cover ratio of at least 35%. If it's more than 35%, the text will be green. If it's less than 35%, the text will be red. Let's see what happens if we select a fan that is smaller. We go to the fan tab. In the fan specification block, we go to fan diameter. Let's make that 7 meter fan in diameter. Let's go back to dimensions, and you can see the fan cover ratio text is red, and it gives you the fan cover ratio of 26.7, which is less than the recommended 35%, and you can see that the fan is too small. The second design guideline shown on this tab is the height of the plenum chamber. If the plenum chamber is not high enough, these lines will be red. There should be, according to design guidelines, at least a 45-degree angle from the tip of the fan to the edge of the cooling tower. If it's less than that, these lines will be red. So if we make the plenum height, in this case 1, you'll see that the plenum height is not high enough, and the tip of the fan does not cover in a 45-degree angle to the edge of the cooling tower. The minimum plenum height, according to the diameter of the fan and the frontal area of the cooling tower, is given here. In this case, it's 1.73. If it's less than that, these lines will be red. If it's more than that, the lines will be green. It may, however, be necessary to increase that height to obtain a practical cooling tower design. The last tab on this screen is the fan layout, and it can also be used for fan coverage calculations. The figure you see is the top view of a cooling tower with the width of the cooling tower and the breadth of the cooling tower. And in this case, there's only one fan. You can input the number of fan rows in the B direction or breadth direction, and you can also change the number of fans in the W direction or the width direction. The top view is based on the dimensions that you've entered here. So we can change the width of the cooling tower to 10 meters. And as you make the change, you'll see the difference in the picture below. So firstly, we can do fan coverage calculations. You've got another input, and that's the fan percentage size. If you increase the fan percentage size to 100, you can see that the fan is 100% of its allowable width. And if we make it smaller, you can see that the fan becomes very small. Sometimes it might take a while to update. And as you change the fan from 0% to 100% of its allowable size, you can see that fan diameter in meters, the fan diameter in feet, because most fans are specified in feet, and also the coverage percentage. So if we increase this number to 72% of the size, it will update the diameter in meter, in feet, and coverage. And then you can play around with this until you are happy with a big enough fan with a coverage percentage that is acceptable. One can then also increase the number of fans in the different directions. So if we increase the number of fans in the breadth of the cooling tower, we can change that to 2, and you'll see there will be 2 fans. And now the newly calculated coverage percentage is 27. If we increase the number of rows in the width, you can see that it will include 4 fans, and the coverage ratio is 37. And now you can increase or decrease the size of the fan until you get an acceptable coverage ratio, or you can change it to get an acceptable fan diameter. So let's say there's a 14 feet fan that you want to specify, or maybe let's do it a 13 feet fan. We can decrease that number. You can see that the diameter that we've chosen is 12.6, and now we can increase it again a bit. And this is trial and error until you get an acceptable fan diameter with an acceptable coverage ratio. This has got nothing to do with the rest of the cooling tower package or software. This is just helping you with the fan coverage calculations if there are 1 or more fans. Just remember, if you want to specify more than 1 fan, that you have to manually increase the number of fans to 4. This is just a tool to help you make the decision, but the values are not automatically carried through to the rest of the software. You also then need to specify the appropriate fan diameter and the fan characteristics that we'll discuss in another video.